Today, I'm going to talk about RFID and dive in a little bit deeper on NFC. Overall, we'll be scratching the surface on both, but hopefully you walk away with something that you didn't know before. Again, today we're going to be talking about RFID, NFC, and I'm going to blow through these slides real quick so we can get to the good stuff. Down at the bottom there, the demos. All right. RFID, radio frequency identification, is using the electromagnetic spectrum to identify and track tags. These tags are often associated or attached to or integrated with objects. So really what we're trying to do is track objects and or exchange data. Because these tags they store identifiers and information. They operate at varying distances and can be either passive or active. While passive versus active is somewhat straightforward, it's important to note that the passive, of course, has no integrated power source, doesn't require power, and utilizes the receiver, the reader, to interrogate it. With this, there's limited range. However, they are cheaper and easier to manufacture, and have an exceptional lifespan, effectively the life of the hardware itself, as there is no capacity limits on a battery. We typically see passive tags in the LF, HF, and UHF spectrums. On the other side, we have active. Active tags require a power source, either integrated or external, to be connected. They do offer extended range, but as you can imagine, are a little bit more costly to manufacture and end up being a little bit larger, relatively speaking. We usually find the active tags or devices in UHF or microwave spectrums for longer range implementations. Okay. LF, so here's again the frequency spectrums that we see typically NFC stuff, and of important note, just real quickly, low frequency is less susceptible to environmental interference. So we see these tags on things that are outside typically, or in industrial, like rough environments. So animal trackers, access control, again, industrial applications. HF works at 13.56 megahertz, offers a faster transmission rate, and includes NFC. This is where NFC lives. You see this all over the place. It is ubiquitous in our lives these days. We have contactless payment systems, smart cards, document management. We'll go through some more use cases and examples later on. And then finally, UHF is, again, longer range and typically larger, but we see these in like supply chain management or big asset tracking, freight management kind of stuff, race timing, or traffic control, like your HOV lanes, toll booths, stuff like that. NFC is a subset of RFID. So within RFID broadly, NFC is again a subset that offers short-range two-way communications. Again, we see ID cards, key cards, payment systems, stuff like this. The real thing, whoops, one slide back here real quick. I want to hit on the more secure, in air quotes here. Like generally speaking, and colloquial, I'm not even going to try to say the word colloquially. It's thought to be more secure because of the close range that you have to be to interrogate a device or interact with a reader. So we're not throwing signals over long distances that would be susceptible to man-in-the-middle or eavesdropping attacks. So there is some inherent security. That's the wrong word for it, but that's how people think of it, I think. By virtue of just being limited in transmission range. Okay, highlight the significance of NFC in mobile, and that's, we all have, I'm making an assumption here about y'all, it's fair to say that at least most of us have modern very smart phones in our, on us at most times, offering, one-tap interactions, tap to pay, secure transactions, device discovery. Something I didn't really realize when I first started this, or as a user, I guess, before I started digging into NFC more, is how many things use NFC to initiate other protocol interactions. So, like my headphones here utilize NFC for device discovery. I can actually scan it with my NFC scanner, which is kind of cool. And then the pairing process takes over with Bluetooth. Also, via our mobile phones and NFC, we can do contact sharing, peer-to-peer comms. Again, your Google Wallet or your Apple Pay, payment terminal kind of stuff. And then IoT, so especially when it comes to smart home devices and wearables or connected gadgets. So it's not just the interaction with those devices, but also the control. Is again really ubiquitous, and more and more do we see that stuff in our households or environments where we work. I'm going to quickly go over some of the hardware that could be used in RFID research or NFC research and security testing. So the first is ACR122U, made by ACS, or Advanced Card Systems. It's old, kind of feels clunky, but it is a cost-effective, like around $20 reader and writer. It's really easy to get a hold of. It's USB and it works with every OS. One limitation is that it's HF only, so you can't do LF reading or writing any interaction. And it does support a broad range of HF chip or tag protocols. So it's a good tool. It is versatile and offers some real-world functionality when paired with software that uses it. Sorry, I'm holding one here, the picture on the screen. But paired with software that can utilize it or make it easier for the user to engage with the tags or devices or whatever's being scanned. So you could see this as contactless payment. You can use that. There's like race check-ins or timing. There could be front desk check-in kind of stuff. Really anything that uses HF cards, you just need that complementary software to engage with it, typically. Developers, more security-minded folks, researchers, there's plenty of ability to interact with this and use it at that level. Just I wouldn't give it to my mom and expect her to be able to do a whole lot with it, without complementary software. So it's certainly developer friendly, and I'm not trying to steer you away from it. It's a absolutely excellent option to start diving into RFID research and testing. Okay, a much more complicated and expensive tool is the Proxmark3 or Proxmark family of tools. So it adds LF, so it has a LF and HF antenna installed. This one in particular has a Bluetooth module you can see here, and that is not just for remote connection and control, but also it has this battery capacity, so I can use it for offline attacks or what we call standalone mode. It has the ability to read, write, and emulate on both frequency spectrums, and is primarily used in pen testing and security research. I'm sure you could write complementary software that uses this as like a badge-in kind of system or a contactless payment. It's just not. It's not what you would buy for that. You don't need all the complexity that comes along with a Proxmark to do that kind of stuff. Also, it's kind of neat, when somebody's coming up to the front desk or to check in, like having something big and bold that says NFC and not something kind of funky looking that you can see the PCB board on. Anyway, the Proxmark is supported by an open source ecosystem. It's well maintained and regular updates. There's tons of documentation, but more like wikis and stuff like that. And and is always evolving in capability. It's, again, a little bit more sophisticated, but readily available tools make it certainly approachable. It is made for Windows and Linux, or at least the typical firmware and command line SDKs, stuff like that, are for, the build is for Windows and Linux. And Mac is technically possible, it's just not really focused on. So your mileage may vary. My MacBook that I'm working on right now is a little bit too old, and I found out, the hard way. Again, technically possible, just not as straightforward. Okay, Chameleon Ultra. This is a very tiny version of the Proxmark, is the easiest way to describe it. It does all the things that the Proxmark can do, and is a little bit more user-friendly for standalone mode. It has its own battery that holds a pretty good charge. On paper, 6 months, but your mileage may vary depending on how much you use it. Very small form factor, so it's great for pen testing and security evaluations, or physical pen testing or evaluations. It has simple push button operation in standalone mode, as well as a GUI, but the push buttons is really where it shines, because the Proxmark has a single push button, which works, but is implemented different depending on what software you're using, or what firmware you're using. So how you have to dig through the code to figure out how the button is going to react, or how the Proxmark is going to react when you push a button for duration or multiple times or whatever. On the Chameleon, it's standardized. So not only is there a second button, which, as silly as it sounds, makes a world of difference when you're trying to initiate things and control a device. Having two buttons is way easier than having one. But also the LED implementation is standard. So each LED, here you can see in the picture 1 through 8, there's 8, it represents a slot for card storage or emulation. So it's easy to see kind of what you've selected. You kind of have to remember what's loaded, but that's fine. Again, there is a GUI you can connect to through Bluetooth or USB, and visualize all that in a GUI form if you need to. Again, there's an active community with regular updates and there's a little bit less documentation than Proxmark, but still you can get by. Okay, and then Flipper Zero is not specific to RFID or NFC, but does contain some functionality there. It is more of a multi-tool. There's way more to the Flipper Zero than just RFID. We've got IR, we've got Wi-Fi potential, kind of bad USB attacks, and GPIO to program all kinds of stuff, or program and add all kinds of stuff. You can it's obviously compact and portable, but also menu driven, which makes it really easy to get stuff going, and you don't have to figure a lot out, which is nice. It is controllable through USB or Bluetooth, and there is like the Flipper Labs store kind of thing, where you can get apps for more specific use cases as you get more involved in a particular technology or want to investigate something a little bit more. The Flipper Zero is getting increasing attention from regulators and the like, due to people being malicious with it. It's like one of those things that can just be annoying, and so folks that are going to be malicious are going to be malicious. It doesn't matter if it's a Flipper Zero or a hammer. Like, both can be used for the wrong reason or the wrong reason. There's nothing in the Flipper Zero, however, that you can't replicate with any number of other tools. So, and it's not actually one you would probably choose if you were going after a specific technology. So while the Flipper Zero is really handy, it is not as capable as the Proxmark or any of the other devices that I've shown. So kind of depends on what you're getting into. And anyway, just based on the increasing attention by the regulators and everything, it's getting harder and harder to come by. But they're relatively inexpensive, and again, easy to use. They're kind of fun, but it'll only get you so far. Okay, and then finally, NFC Tools is a mobile app, and funny I put this in the hardware overview. It's hardware that you already use, you already have it, you're already carrying it around with you, and your phone already reads NFC. It just doesn't necessarily know what to do with all of the potential records that you could visualize or receive through NFC. So NFC Tools gives you an opportunity. I'm gonna just maybe I'll show you real quick here, playing on my phone in the middle of a video. So I don't know if you could see it. I'll do a better stitch here later, but here's the app. There's nothing to it. Hold a card up to your phone and boom, there's some information. It reads all kinds of things. We got these little NFC end tag stickers, different information, right? And the cool thing is the NDEF records, and we'll get to that here in a sec, but you can store information on these cards or these stickers or these keychains or YubiKeys, or you can check out how many Chuck E. Cheese credits you still have, or you can get into your room at a hotel or an event or something like that. This stuff is everywhere, and having something in your pocket already, like your smartphone, that can read that and give you information at the very least is kind of cool, I guess if you're a nerd like me. But it also comes in handy when we're talking about home automation. I mentioned that before, but with these little tiny stickers, you can automate and make routines and tasks and all kinds of stuff around your house. So one use case might be, you have guests on occasion, and you're a good cybersecurity individual, and you have an incredible password on your Wi-Fi, and it's not broadcast, your SSID. So you just put this sticker somewhere in a drawer or on a shelf or whatever, and if you have a guest over, they can just scan this and be connected to your Wi-Fi. You don't have to talk them through it all, how to find it and type in the password for them and all that. You don't have to manage it. Pretty neat. Again, just to reiterate, they're like the NDEF messages. You can have records in there for URLs or smart, contacts for smart business cards, or you can launch an application or something like that. So it's really cool, especially when you think about using it with your phone, and just kind of always having that ability. Okay, cards. There's many kinds of cards, and here's some. I showed you the Chuck E. Cheese one already. Tesla keys, there's tons of stuff. Today we're going to focus on Mifare Classic 1K cards specifically, and we could have picked any of them and we would have had a whole 30-minute video on any of them, but if we tried to do all of them, it would be 30 days, not 30 minutes. There are pros and cons to each implementation. So various memory capacities, security is, let's say, evolving. So as generations of cards get developed, the security mechanisms get compromised on the old ones, so a new generation is created with new security implementations. I chose the Mifare Classic 1K because it is ubiquitous in our lives. Like, you see it all over every time, every day. It's everywhere. So it's your bus tickets, it's access control, like getting into buildings. It's Teslas use it with the key card that they have, albeit much more secure than the Classic 1K. But the Mifare broadly is everywhere. The Classic 1K is the security is compromised, so we're gonna be able to view some of the block data and sectors, but it's so widely implemented that to replace it all is cost prohibitive. So it's a cheap solution still. It's good enough security for a lot of things, bus tickets, right? Like stuff like that. So and there's a lot of compatibility. So as you'll see, or as I mentioned with like the Chameleon, you can have 8 different cards on there, and even better if one of those cards, like one of your Mifare Classic cards can be programmed to work on several door locks, or it can do, you know, facilitate access or control to a number of things. So it's 8 times however many functions that one key has. So it's pretty neat. All right, caveat, Mifare has what's called magic cards, and there's several generations of them. And the key here is that the UID, the unique identifier of the card, can be rewritten in varying methods. So typically when you buy, let's say, an access control system for your office space doors, the vendor will implement a locked, like manufacturer locked UID, so that it can't be altered, right? This immutable ID is a security feature that identifies each unique card so that you can program these unique cards to work with your locks and nothing else. Well, that works for most people. When we have magic cards for testing and testing only, we can emulate that UID. We can rewrite the UID and or simulate, I guess is maybe the better word, simulate that we are that card. Obviously, as things need to be more secure, again, like I mentioned, the Tesla key card, it implements more security than just a unique identifier as the authentication method. So anyway, the magic cards are almost required for security research as we're going through this, or at least some ability to emulate some of the functions and rewrite some of the data. Often, though, the UID needs to be rewritten to be authorized at whatever reader or implementation you're trying to test. So really quickly, there's all kinds of generations. Each generation has a version of it. I won't go through all of them, but Gen 1 cards are the most common magic cards, and they require a special unlock code to be sent, or command to be set. And if you do that wrong, or if you set something in that sector 0 incorrectly, you can brick the card and it's not recoverable. So something to keep in mind, but they are like relatively simple to get and relatively cheap compared to the other generations. They're also detectable. So if you're doing a true penetration test or security assessment, physical security assessment, and a system is looking for magic cards and denies them, it won't work, right? So it is obvious that it is a magic card. Okay, Gen 2. Gen 2 is really cool because you don't have to send it that unlock command. So you can write to it with your Android app, for example, the NFC Tools that we showed earlier. It too is detectable, so something to keep in mind. But you know, a lot opens up when you can just have one in your pocket and rewrite it at will without having to have, you know, a whole setup here. Gen 3 implements a 7-byte UID. Unlock is required, and the benefit to Gen 3 and beyond, or at least Gen 3, again, look at the versions, you see what's current as of as of you viewing this, not as of me taping it, but at least it can be lockable, and that makes it not obvious that it's a magic card anymore. So that's pretty cool. Gen 4, the one thing Gen 4 adds, 2 things, is that it has shadow mode, which is pretty cool. You have a card that's totally normal looking, and you can implement shadow mode that does a one-time answer, like one-time interrogation, and then reverts back to what looks like a normal card. So you can have it, you know, for it is your bus pass, but then you put it in shadow mode for one time to open this office door, and then if anybody looks after that, it's a bus pass again, right? Kind of cool. Terrible analogy, but hopefully you get the idea. And then Another cool thing is you could, this is kind of doesn't make sense when I say it, but you can brick it, and it's at least technically possible to recover that. So there's some commands you can send to like reset and effectively unbrick the card, which makes it much more useful again as you're testing new things out, and also makes the cards more expensive. So I think the price increases as you go up in generations just due to the complexity of what it takes to make them so. Okay, this is what we came for, right? So I'm going to run through some demos real quick about reading data from a card using the Proxmark, and then we'll read data using this, the same card using NFC Tools on our phone, and we'll view the NDEF records on each of those, and then we'll use our phone to write NDEF record. We will follow that with emulating UID using the Proxmark. So that's where I have a card, and I want my Proxmark to act like a card, right? So maybe I could take this offline, or I get control of a card for a moment. I can copy that, or I can get enough information from a card any way I get it, so that I can at least emulate the UID, which is that initial authentication kind of mechanism, and see what that gets me. And I don't need a card. I don't have to write to a card to do that. I can just program my Proxmark to do that. And then finally, we will use the Proxmark to write to a new card. So I'll take one card and copy the dump, and then rewrite another card so that it acts the same. It'll all make sense, hopefully. My test mechanism here is a cabinet lock. It's an electronic cabinet lock. I'll show this to you. I'll switch around the video so it's a little bit easier to see and everything as we start the demos. But it's a cabinet lock. There's a good beep and a bad beep. That's good beep. This is bad beep. Right? Makes sense. Okay, so as we're going through that, we'll see what happens. Okay, I had to switch up audio on you here. I'm running out of USB ports, but hopefully I'm still coming through all right. Okay, here's my lock, my cabinet lock that I'm testing against. Turn it around here, see lock one. I've got my Proxmark hooked up and plugged into my laptop, and then I've got my Kali instance sitting here with Proxmark already loaded and the new firmware flashed. Okay, I've also got a couple of locks, cards that I know work with this lock, so we could test those for good beep, right? And then I've got a known bad card, so it doesn't have the right configuration, whatever is necessary. Bad beep. Again, I hope that's coming through on audio. Let's see. So what I want to do first is I just want to read card data from the card using Proxmark. So I'm going to take one of these known good, and I just want to see what I have here. So over on my Kali, let's see, click in there. Yeah, demo time, I can tell. There we go. A lot going on here. Okay, so we enter the Proxmark Iceman program here. Pause for effect. There we go. All right, so, sorry, one more thing. All right, what did I say I was going to do? Oh, good. Demo time. Let's try again. All right, so we've got Proxmark. We're in there, and I want to, again, read data from my known good card. So backbone going. Now everything's popping up. That's good. Too many shells. Okay. So you can always type help in here for command assistance here. So HF antenna is what we want to use. MF is for Mifare. And let's go straight to, let's do search. That's going to help us find our card. Sorry. Let's start like we don't know it's a Mifare. So we're just going to do HF search and see what pops up. All right, so it's telling us that at least it's possibly a Mifare Classic 1K. And then it gives us a hint as to some follow-on commands we can run. HF MF, again, because it's a Mifare. So let's let it finish making sure it's nothing else. HF MF info is what we're going to try next to try to get some additional information off the card. While that's running, let me switch screens here. Cool. So we got some keys. One of the key takeaways here is we got the UID. We want to record that for sure. I write it on the card as I change it, or at least, in the case of a magic card or something, I use what it originally was, and then I can always reset it if I need to. All right, so I've got the UID. I've got some keys that are in the default dictionary. Like there's a whole dictionary, just like everything else, of compromised keys. So that's what we're using here. And then, so we want to see if this card has any NDEF messages on it. So HF, MF, NDEF read, and this being a regular classic Mifare card, yeah, so this one is not properly formatted NDEF message. There's not going to be anything. Or it's not going to give me what the message is. That's fine. That's what I expected on this one. It doesn't actually, that was me messing around with it earlier. It doesn't actually have an NDEF message on it. It just has the header for where one would be. So it's not able to show me a record. That's fine. That's what I expect. Now, we can do the same with our, well, that worked. Still works. That's good to know. All right, so we can do the same with our NFC Tools app, right? And if I just lay my phone over that card, again, I can get some information. For whatever it's worth, it'll give you what it can on the card based on the technology. The serial number is the UID, so it calls it serial number here, but that's the UID, and that's what we need to pay attention to and definitely capture. Okay, so if we do the same, just as an example, we have NDEF data on this magic card here, and you can see, like, I've got a record. I hope you can see. There's a text record here that says "good stuff here." So it's just a text record. You can store all kinds of data on it. I'll let you dig in and figure out, how you can, what kinds of records you can put in there and do all kinds of fun stuff. But that's a really simple way to read a card. I mean, look at all this information that we have just from the phone that we carry around in our pocket, all the time. So super handy. All right. Sorry, before we move on from that, what we can also do, this is upside down, so let me try to do it upside down for me, is I can add a record. So I can add, some other text. Let's do DMO. Demo text, and then it gets finicky. These magic cards are more and more finicky as you try to do more things to them. But write and approach. Okay, so it wrote the record. So now if we go back to read the records, move it, re-engage. Okay, it didn't give me anything. Hang on, they're finicky. So if you know you have a magic card, keep trying, because it gets a little bit silly. There we got it to pop up. And I'll show you my trick for using it on the Proxmark is even worse. But it's tiny text here. Hopefully you can see demo text, that added record that we have. So that's pretty cool. All right, so moving on from NFC Tools, we want to emulate a UID using just the Proxmark. So again, we have this lock, and Proxmark doesn't do anything. This card we saw has bad beeps, and then we have a card that has good beeps. So again, I've written this UID down. So I'm just going to give it the command to simulate this message. So here we want to do HF, MF for Mifare, sim for simulate. We've got to give it the card type so it knows where and how much data to emulate or simulate, and then the UID 339 BCE. Okay, and so my Proxmark, you can see on the command line there, is now simulating, and good beep. Pretty cool. And then to stop that simulation, we just press the button on the Proxmark. It's okay to have one button in this case, and then we're back to passive, right? Nothing going on. Pretty cool. And we didn't need an extra card to do that, so that's nice. Let me show you what a pain in the butt it is to clone one of these things using a magic card, or at least some of the magic cards. All right, so the final demo I want to do is cloning to a magic card. So this is a magic card. Thankfully, this one's very clear and obvious. I have another stack of them here of different types of magic and different, varying levels of difficulty when you actually try to do something with it. But as long as you know and you've done the read and you know what you're dealing with, then you just you might need to change orientation or distance or something like that to make it work. And we're going to have some trouble here, I can imagine. We're going to do it anyway. All right. So now I don't actually need to clone this card. What I want to do is just set the UID. So in the case of this particular lock, the only thing it's doing is making sure that the UID is programmed for authorization, like to open the lock, and that's it. There's no special sauce in the data to further ensure that card is allowed. So all we have to do is replicate the UID. All right, so I'm going to try this. Set my magic card on my Proxmark, HF, MF, set UID, and then that same good beep card that we know. All right, and that's going to fail because it's a magic card, and magic cards are finicky. So I have found that a good solid peanut butter and jelly sandwich in between the two is perfect distance. In lieu of that, I've got a couple pieces of foam and a piece of paper. And as silly as that sounds, let's see if we can get it to work on the first try. Done. All right, so if you happen to have a piece of paper folded in quarters and two pieces of small foam, then you're good. Otherwise, I'll hover it with my finger and just try to adjust. I know it's a magic card, so I know it's going to work. I just need to get the right orientation and distance. Okay, so we can see on the command line here is that we've written a UID to this card, and if it all went right, we should get good beep. Great success. Okay, and that wraps up the demos. I know it was quick, trying to fit all this in without boring you to death. Already over 30 minutes, but we're gonna send it anyway. What the heck, right? Obviously, there's a million more things you could do with just this equipment, and it's fun, right? It's fun to test things out. It can make add some convenience to your life, if nothing else, and at least for the purposes of security testing, the basic things you want to be able to do is read the card and read the NDEF records that are on the card. The emulation and everything else, whatever your tool, is totally possible, and even cloning full cards, that's totally possible. We watched the rewrite of UID here at that last, on that last demo. So obviously comes in handy. If I have a UID that I know is good or should be good, then I can transfer that to a card somehow or emulate it with a hardware device, and I can have like access. I can have equivalent access to whatever that card had for testing purposes only and demonstration. All right. Well, thanks for watching. I hope you learned something today, and look forward to hearing what you come up with on your journey.